The first time that I came and collected a water sample from Hubbard Brook was, I think it was March. It could have been April, but I think it was March in 1962. And Bob Pierce from the Forest Service and I went up into the watersheds, and we went to watershed 6, and I collected a sample of stream water. So that was the very first sample that was collected by me here at Hubbard Brook, and probably the first sample that was collected for chemical analysis at Hubbard Brook.
I've been working at Hubbard Brook for over 20 years personally, and a lot of that time, a lot of the projects that I've worked on really start with looking at data in the data archive, or thinking about samples that are sitting there in the sample archive that have some information about them that could really teach us something. Oh, if I went back and resampled that, we could see if this thing has changed, soil carbon and nitrogen ratios, or tree growth or anything like that.
The forest has been really changing since like the 1920s. So actually one of the first goals of the creation of the Forest Service actually was to do fire prevention. You've heard about the Smoky Bear. The reason why recently there has been a lot of scares around wildfire is the fact that we didn't do a really good job at like forest management, and so when they happen out of nowhere, the effort to put them out is very costly. Obviously, it affects all the people that live around the wildlife-urban interface. But I think once we get a forest management going, that would really help with thinking about what kind of risk is associated with it and what timeline would look like for a fire to happen.
So when you have a record of 2 decades versus say 5 decades, you're going to see slightly different trends. So the more data you have, the more important it is to really look at those long-term trends. So it's really important to collect data from all of these different sites to get a bigger picture of what's going on in the New England region.
Ecological processes take decades to centuries to play out. And so having places like Hubbard Brook, where we're able to monitor everything, streams, vegetation, climate, lakes, biogeochemistry, all these things allows us to really understand how these processes have changed over time in response to a changing climate and changing land use and human uses and all of these things. So long-term resources like Hubbard Brook are absolutely critical for understanding how these processes play out.
And the data available at Hubbard Brook is really great, really well documented. So even things like thinking about how you do sorption, there's great soil data from Hubbard Brook. You can't ask for much better than their high-resolution stream flow and stream chemistry data. You have rain data, you can tell the rain chemistry with really high accuracy, so it's a really special data set.
We're pretty unique at Hubbard Brook for measuring stream flow during the winter in a kind of northern cold environment. Some people would call us a little crazy for trying to do it. But we do a pretty good job because we've kind of, come up with different methods for dealing with ice and freezing equipment and weirs and things like that. So you can kind of see it here. The wood from the hood that we have built around the weir, so it kind of insulates the V-notch underneath the plywood, and we actually put a propane burning heater that's floating in the weir. So yeah, Hubbard Brook is really unique for being able to still measure stream flow during the winter.
We know that snow is melting earlier at Hubbard Brook. And so even though the timing of snowmelt that we were able to see over 10 years wasn't significantly earlier, it's still sort of fitting in with this long-term, very significant pattern that we've seen for decades on Hubbard Brook. And so that's a key reason for doing work at the site. We're also able to take advantage of the long-term measurements of plant phenology. And so by that, I mean these really important life stages for plants. So, when do they burst their buds? When do leaves emerge? When do they fully unfold? When does leaf out happen? And there's a record at Hubbard Brook that goes back for, I think, over 20 years, 25 years, since the 90s, that Amy Bailey and her colleagues have been collecting.
The scientific questions are unending. And the longer we do it, the more valuable it becomes, or we're positioned to ask different questions if we've been manipulating the forest for 10 years.
At Hubbard Brook, where we already have decades of data, that really lets us have a lot of confidence when we do a manipulation or when nature creates a disturbance like the ice storm or like some of the invasive insects that are coming through. It really gives us a good idea of what change is driven by that particular disturbance or experiment versus what's just the natural year-to-year differences.
Because so much is changing in the moment, like with climate change and with these forests, so much is changing in the moment, and then these cycles are so complicated to begin with, it's just kind of fascinating to try and figure out the parts of it that we can make more sense of so that we can get to those answers of what's going to happen and how can we help these forests survive in this changing world and help ourselves survive by helping these forests.